Let's discuss binomial distribution. We already discussed this example, tossing a coin 2 times. There are many similar examples like tossing a coin. In a factory, if you inspect a product, you can classify either defective or good item. Or if you ask one voter about whether she likes a certain candidate or not, well, it is similar to tossing a coin. Well, the characteristic of this experiment is there are two possible outcomes, such as defective normal, pros and cons. But the probability of outcome may be different. Probability of defective, normal, probability of pros and cons. We call the single tossing a coin-like experiment is Bernoulli trial. One outcome of two, we call it is a success. The other one is failure. This kind of Bernoulli trial can be studied in depth here. Well, what I mean is it can be extended. Bernoulli trial can be repeatedly over time. And then we count number of success. When you toss a coin 2 times, we count the number of heads like that. Throw 5 coin 5 times, and examine number of heads. Inspect 100 product, count the number of defective product. Number of voters in favor of a certain candidate. Well, this situation, counting number of success, we call this is binomial random variable. Here's another example. If you go to Science Museum, you might see this device. At the top, at the roof, they drop the ball. Okay? Then this ball will hit this place, this circle. Then there's a chance, a half chance whether it goes to right or goes to left. Well, if the ball hit this position, there's another chance he can go to right-hand side or left-hand side with a half probability. Actually, this is a simulation of the binomial. If you give 1 point, if it is in the right-hand side, give 0 point in the left-hand side. Well, if you accumulate them, we are counting number of heads. It's a simulation of binomial. Here's an example. The Tiger team, the baseball team, has a 60% of a chance of winning every game this season. What is the probability of losing all of them, winning only once, winning twice, 3 times, all 4 times? It looks like this. We should think about all possible cases. This is the sample space, okay? I mean, winning, lose. Lose means X, winning is O. Then what does it mean Tiger will lose all games? It would be this event. How can you calculate that? Losing chance would be 0.4, but the first game, next game are independent. We just multiply them. What does the chance of winning once? It represents this kind of event. We are looking for this probability. All this probability is winning 1 times is 0.6, losing is 0.4, it's a cube. And there are 4 cases, that's 4 combination 1. I mean, find the location of O. It's a 4 combination 1. Similarly, winning 2 games represent this kind of event, and winning 2 times is 0.6 square, and then losing is 0.4 square. It's because they are independent, and there are this amount of cases. That is for combination 2. You can go on. It's for combination 3, winning 3 times, losing 1 times. Here, winning all times. Well, therefore, it is for combination 1. It's 0.634. Well, if I summarize this is probability distribution function of x, the number of games Tiger wins. X is 0, 1, 2, 3, 4. Okay, these are the probability. This is a binomial function. Using E-stat, you can easily experiment. You can calculate probability. If you have a PC, would you open the E-stat? Preferably the browser is to be Chrome. This is the main screen, www.estat.me. Click eStatU. You will have a menu like this, but here, maybe you can click here, binomial simulation. This is what I showed you. Okay. Well, if you click execute button, it's probability of chance of 1 is 0.5 cases. It looks like this. We drop the ball. We are watching how many times it would be here. Since there are 2 branches which give you 1 point, well, it has more probability than the other. Well, you can do experiment, some more value, like tossing a coin 10 times a simulation. You can watch these things. Okay. Then how can you calculate a binomial probability? It looks like this. It's a default graph, but in our Tiger team cases, we play 4 times. Then you type 4. Winning chance is 0.6. Click execute button. They will calculate all the probability like this. This is the same one. If you click show probability, they're gonna show detailed probability. If you need a table, maybe click this binomial probability table, then you can see that these are the all probability from 0 cases to 4 winning. Here's exact probability. You might be curious about why we studied cumulative distribution. This is it. Sometimes we need to calculate probability. Well, this is cumulative probability. From 0 is the same thing. 1 is the addition of these 2. This is addition of 3, and so on. You may need that some kind of inverse probability starting from 1. Well, you can subtract this number like this. Therefore, if you need to calculate, maybe E-stat would be helpful. You can answer what you want. In general, the binomial distribution has a function like this. X is counting number of heads, number of success. Therefore, it has chance, possible value 0 to the n. Okay? In case of a winning game, maybe we are losing all time. And then expectation of binomial, we can show that it is NP, but at this level of statistics, we are not proving this. Okay? Variance is NP times 1P, 1 minus P. Well, you can watch several cases of binomial. Maybe you can practice using E-stat easily. Suppose you switch these things, maybe this is 20. If success probability is low, although it is 20, it look like this. Maybe you can increase more, and success probability like this. You would have a distribution. I mean, later we'll study normal. I mean, it is symmetric about the mean. Well, you can see that. I mean, this is maybe can be approximated normal. Maybe I can show that by clicking this. Okay, this is the normal distribution. Well, why don't you practice these kind of things? What's next? As an example, past experience show that a salesperson from an insurance company has a 20% of chance meeting an insuring person. 20%. He's gonna meet 10%. What is the probability? Maybe this one would be easy. Suppose you're gonna meet 10%. That means you're gonna have n equal 10. P is 20% chance. That's 0.2. If you click execute, this is the graph. Okay? This is the chance. Then you can answer everything. Well, you can show the probability. Also, you can find the binomial distribution table. Using this, you can answer. What is the first question? What are the probability that 3 customers will get insurance? 3 customer means like this. So you can answer 0.21. Well, initially you may practice some combination formula, but once you understand what's going on, you can use E-stat easily. What does it mean, 2 or more customer? At that time, you might need this one, 2 or more. That means this probability, maybe you can subtract these two probability from 1. Or you may calculate 2 or more, maybe this probability. How many people on average would sign up? Well, you have n equal 10, p equal 0.2. Well, you can guess that it is n times p. We expect 2 customers would sign. Well, similarly, you can answer everything. Maybe that's all for the binomial distribution. Be sure we have 2 outcomes, either head or tail. We are counting number of headers. I think each step will help you to calculate probability. Okay, see you on next lecture.